Shapes of distributions actually dictate which measures of center and spread we should use to describe the overall distribution of the variable of interest. Therefore, assessing shapes accurately is really important. When the distribution of a variable like home selling price is displayed, the x-axis typically displays the variable values and the y-axis displays the frequency. Shapes are classified into two categories, symmetric and asymmetric. Symmetric distributions include uniform and Bell primarily. To remember uniform, think of a sports team. They wear the same uniforms, so they look the same. The y-axis is frequency, therefore the frequency of each number is about the same for all variable values. The outcomes when rolling a die represents a discrete uniform distribution. It is discrete because there are a countable number of outcomes, only 6, and it is uniform because each of the 6 outcomes is equally likely to occur. In this case, the y-axis is probability, or the proportion of times we expect each number to be rolled. A variable with a uniform distribution can be continuous. A random number generator will generate real numbers between 0 and 1. There are infinitely many real numbers possible in the interval, making it continuous, and all numbers are equally likely, making it uniform. The other common symmetric distribution is the most important of all shapes. It is the bell shape. It can be discrete or it can be continuous. The primary asymmetric shapes are skewed left or skewed right. If the data tapers off to the right, it is skewed to the right. If it is skewed left, the extreme scores are spread out to the left. The reason the shape dictates what measure of center and spread we report is because the mean and standard deviation of skewed data are greatly influenced by extreme scores as well as by outliers. Thus, they become bad representations of the entire distribution of variable values when a distribution is asymmetric or outliers are present.